Okay, so let's finish up this lesson on basic differentiation rules and rates of change. We're going to be talking about that in a second. So first, let's start out. They've got more examples about that basic rule. What happens if you have more than one term in a function and you're asked to take the derivative of it? You just do the derivative of each piece separately. So this is going to be f prime of x equals, this one would be 3x squared. This one would be minus 4. Technically, that would be x to the 0, but you don't have to write that. And then the derivative of any constant, 5, is 0, so I can leave it off as well. So that's my derivative. This one, I would rewrite that first term as negative 1/2 x to the 4th out separately. Then plus 3x cubed minus 2x, then do the derivative of that. So g prime of x equals, so let's start with this term. I would bring my 4 down front, so negative half of 4. That'd be negative 2. That would become x to the 3rd. Plus, this is going to be 9, and then x squared. And then minus, that would be 2x to the 0, or just 2. Because remember, this is a 1 right here. Okay, this one we're also going to have to rewrite. So anytime you have a variable in the denominator, I would try to divide that out. So I'm just going to take each of these terms divided by x. So 3x squared divided by x is 3x. And then minus an x divided by x is 1. And then plus 1 divided by x. I'm going to write that, instead of writing it as 1 over x, I'm going to write that as x to the negative 1 power. So this piece right here is really 1 over x, which is x to the negative 1 power. Okay, so then my derivative, y prime in this case, equals, the derivative of 3x is 3. The derivative of a 1 is 0, so I can just leave that off completely. And then the derivative of this x to the negative 1, I'm going to bring the negative 1 down front, so negative 1 x minus 1 from my exponent, that makes that a negative 2 now. And then I'm going to rewrite this because I can't have a negative exponent. So I've got this 3 out front that's normal, minus, this would be 1 over x squared. Just to give you a heads up, in the back of the book, if you're ever looking at answer choices, they're pretty particular about getting a common denominator. So you might see an answer where they said, I'm going to put 3x squared over x squared minus 1 over x squared, and then combine those terms. I'm fine with you leaving your answer like this, though. As long as there's no negative exponents, it's fine. Okay, so this section right here, these are two big rules that you just have to memorize. This is kind of the beginning of the memorization. So the first one is, if the function is sine of x, the derivative of sine is cosine. The derivative of sine is cosine. The opposite happens with cosine. The derivative of cosine is actually negative sine. So this is just something you have to remember, that the derivative of sine is cosine, the derivative of cosine is negative sine. So remember those two rules. So when I do example 8, I need to know that. So the derivative of 2 sine of x, well, the derivative of sine is just cosine, so that 2 can stay put. This is just like a constant up front, and then the derivative of sine is cosine. This one I would rewrite because there's a fraction, so I would make that 1/2 out front and then sine of x, which means the same thing is going to happen as what happened right here. That 1/2 is going to stay put, the derivative of sine is cosine, and then you could put that back into fraction form if you wanted, or you could leave it like this. This one, the derivative of x is 1. Then the derivative of cosine is negative sine. So that made that a minus instead of a plus. This one, y prime, equals, my cosine would be negative sine, and then minus, this is just a constant, so make sure you're careful with, anytime people see pi, I think they automatically think, ooh, it's a variable of some kind, but it's not. That is a number. So this is a constant, pi divided by 3, so I'm going to leave that, pi over 3, and then the derivative of sine is cosine. Okay, one more memorization today. So there's 3 that you have to memorize for today: sine, cosine, and e to the x. This one is the easiest of all of them. The derivative of e to the x is e to the x. It doesn't change. So on this one, when I have 3 e to the x, I really just have 3 e to the x. So that does not change at all. That constant stays put, and the derivative of e to the x is e to the x. The next one, this first part, x squared would be 2x, plus the derivative of e to the x is e to the x. This one, the derivative of sine is cosine, minus the derivative of e to the x is e to the x. Okay, now let's get into some application problems. So those were all, that was about 1 million examples of just basic functions. But now they're going to start giving you some word problems to think about. So in example 10, they say, I've got this billiard ball. It's dropped from a height of 100 feet. The ball's height, S, so S is typically used for a position. So where is it in the air, right? So the ball's height is S at time t, so they're using t for time, and here's our position function. So S equals, or they could have said S of t, equals negative 16t squared, so this is your gravity, pulling it down, and then plus 100, that was where its height was. So none of this first part really matters too much, except just to tell you what S and T are. So this function is really important. And then they also told me that S is measured in feet, so we're talking about how many feet above the ground is it, and then T is measured in seconds, so how much time is always going to be in seconds. They want me to find the average velocity. Now we need to talk about velocity over each of the following time intervals. So these time intervals that they've given me. So let's talk about velocity for a second. When I talk about position, so S of t, that is just my normal function. V of t, so the velocity, is actually the derivative of the position. So S of t, which was this function right here, the derivative of that gives me the velocity. So that's the first thing that I'm going to think about. Actually, I can actually think about this a little bit easier. So I'm going to go back for a second. So this is telling me to just look at this interval from 1 to 2. So I can just see what's happening at 1 in that function, and I can see what's happening at 2 in that function, and just plug them in and see what's happening. So I'm going to use my slope formula, basically. I'm just going to use a rate of change. So I'm going to use this idea, y2 minus y1 over x2 minus x1. Do you remember that from, so slope is that formula. So in this case, that's going to be my change in S over my change in time. So I'm saying how many feet am I going per second? That's what's happening here. That's my rate of change. So let's start out with S of 1. I just want to see what's happening at 1. So I'm going to do negative 16 times 1 squared plus 100. So that's basically 100 minus 16. So that gives me 84. And then I'm going to see what's happening at 2. So negative 16 times 2 squared plus 100. Okay, so that's basically 100 minus, this would be 16 times 4. So I end up with 36. Check me on that. Okay, so basically what that tells me is my change in S, I'm going from 36 to 84 because I'm going from 1 to 2. So my Y2 would be this one. I could have switched them. It doesn't matter really what order you do it in. So I could do 84 minus 36 because I'm like, you know what? I want to make sure that my my bigger number is in front. It doesn't matter as long as I'm consistent. So if I do 84 first, then I need to make sure I put 1 first down here. If I had done 36 first up here, then I need to make sure I do 2 first because that was when 2 was plugged in. So they just have to correspond with one another. Okay, so that's going to give me 84 minus 36. That's 48 over 1 minus 2 is negative 1. So I end up with negative 48. And remember, this was feet per second, right? So if I'm talking about velocity, so over time, the velocity was negative 48 feet per second. This negative right here tells me that it was moving down. So the ball was dropping at that point. It was going down between 1 and 2 seconds. It was going down at 48 feet per second. Okay, so exact same thing with this one. I already know what S of 1 is, so that 84, I'm just going to keep using that over and over again. But 1.5, I have to know what that is. So I'm going to use a calculator here. Okay, so that gave me 64. Okay, so my slope formula in this case then would be 84 minus 64 all over 1 minus 1.5. And again, I could have swapped those. So that one gives me negative 20, no, sorry, positive 20 divided by negative 0.5. Okay, well, if I take 20 and I divide it by negative half, that gives me negative 40. And again, it's feet per second. So this just got a little more specific. So between 1 and 2, it was a negative 48 average. Between 1 and 1.5, it was a negative 40 average. So it was a little bit slower. The further we get in time, it's going faster, right? Okay, this last one, so again, I need to know what S of 1.1 is. I already know what 1 is. Okay, so this is going to give me okay, I'm getting 80.64. Okay, so this one's going to be a little uglier. So I'm going to do 84 minus 80.64 all over 1 minus 1.1. Okay, so that's going to give me 3.36 over negative 0.1. Which gives me negative 33.6 feet per second. So again, the closer I get to 1, the slower it's moving, 33.6, compared to this was giving me 48. So that average is a lot higher. That tells me at 2 it was going pretty fast because the gravity is just pulling it down faster and faster every second. Okay, so this one I didn't really have to do a derivative on. I really just needed to think about the slope. I started out thinking I needed to do the derivative, but it was a little bit easier than that. Slope is the derivative. This was just, for me, it was easier to do it this way. All right, so then example 11. At time t equals 0, a diver jumps from a platform diving board that is 32 feet above the water. Because the initial velocity of the diver is 16 feet per second, the position is this. So here's my position. when does the diver hit the water? So let's think about what that means. The diver hits the water when their position is 0. So when S, or S of t, equals 0, that's when the diver's hitting the water. So I need to set this equal to 0 to figure that out. So this is kind of just like a quadratic equation, right? When does that equal 0? Okay, so then let's see if we can factor it. That would be the easiest thing. First thing I would do is get rid of these 16s out of here. And I'm going to go ahead and get rid of the negative. So I'm going to divide out a negative 16. So that gives me t squared minus t minus 2. This is going to be much easier to factor. So if I divide by negative 16, this just goes away. And then I'm going to factor out this. So if I do minus 2 and plus 1, that gives me my negative 1 in the middle that I need. Okay, so that means that t equals 2 or t equals negative 1. So we need to think about logic for a second. So t represents time, right? So time could be 2 seconds or time could be negative 1 seconds. Well, since we can't go back in time, I think this one is not a logical answer. So it sounds like after 2 seconds, that's when the diver hits the water, at 2 seconds. So the second part of this, what is the diver's velocity at impact? Now, this one, they've given me this position equation. I'm just going to go ahead and do the derivative because velocity is the derivative of the position. So I'm just going to go ahead and do that derivative. So S prime of t equals, so the derivative of negative 16 t squared would be negative 32 t. And then the derivative of plus 16t would just be plus 16. It would be t to the 0, but I'm not going to write that in. And then the derivative of 32 is 0, so that just goes away. So here's my velocity. This is v of t. Okay, so then I'm going to figure out, they want to know what is the diver's velocity at impact. Well, at impact was when they hit the water, right? Well, they hit the water after 2 seconds. So I really need to know what is v of 2, which is s prime at 2. That's what I'm trying to figure out. So that'd be negative 32 times 2 plus 16. So let's see, that ends up 64 plus 16, that'd be negative 48. And again, velocity is in feet per second. So remember, once you're doing a slope or a rate, there is some sort of rate unit. So feet per second or miles per hour or something like that. So we have to make sure that we take into account our position and our time. So at negative 48 feet per second, that's the velocity. So they were going downward at 48 feet per second.